Hello, I'm Steve Rice from Anritsu. In this video, we're going to talk about how we can mount the ME7838G VectorStar 220 GHz broadband system. And usually, since it's going to be used on wafer measurements, what I'll be showing is some of the ways that we can mount the modules on probe stations. So in this case, we have the MPI TS200 probe station, which is a typical example of how the system might be mounted, especially using MPI types of probe stations. And of course, they have other types of larger probe stations as well to choose from. But in this probe station, we have the ability to mount the modules directly on the MPI MP80 positioners using these brackets. So the brackets are already designed for mounting these modules together with the T220 probes. And of course, there's a number of different features that make it easy to mount the modules and mount the probes, such as, for instance, you can easily slide off the module with the probe in order to have good access to the probes when you want to change them, and then bring them back into position when you have a different set of probes connected. So this is again a quick example of the mounting option that you have when mounting on a TS200 probe station. And what I thought I would do is show how you might be able to mount these modules onto your own existing probe station and talk about some of the existing characteristics of the probe station that you want to be aware of to see if you'll be able to find alternative ways to mount the modules onto your probe station. If there's an interest in mounting the VectorStar Broadband system on an existing probe station, then there are a few things that you want to take a look at in order to consider your options. The first thing to note is the platen itself and how much distance you have over the chuck to mount your positioners. So a typical situation is that you'll have a positioner with an RF probe mounted to the RF probe holder. And so mounting your positioner on the platen will be determined by the hole patterns that are available. Now, in a low frequency type of installation, in other words up to about 70 gigahertz, you might have a probe connected directly to the probe holder, and then you'll have a cable going back to the VNA. And that is a generally accepted approach, but you do want to be aware of the loss of the RF power and dynamic range effects, as well as stability due to fluctuations in temperature with the cable varying in the environment. But that generally is the first approach for low frequency measurements. However, if you're going to start going up into 110, 145, and 220 gigahertz, then you need to get the source of the higher millimeter wave frequencies closer to the probe, and ideally, of course, to be right on the probe in order to maximize your system performance. But in some cases, you might see a situation where you have, for instance, for 110 probe, you'll be connected with a 1 millimeter cable, and then that cable is connected to your millimeter wave module. And again, this is not necessarily ideal because of the effects of cable loss and environmental changes in the lab that will affect the calibration stability. Also, the loss of that cable will degrade the raw directivity of your millimeter wave module source and receive channels. And so you want to find a way to bring this module in direct contact with the probe for maximum performance. Here we have a bracket assembly that will mount the nonlinear transmission line modules directly to a probe, and this entire unit then mounts onto the probe holder. We developed these brackets for demo purposes when customers wanted to evaluate the performance of our nonlinear transmission line broadband system on their existing probe stations in their facilities. The design is a base with the side brackets, and there are different side brackets for different frequency modules. So in some cases, customers have requested that we also offer this with the system so that they can customize the installation with their existing probe station. So we will work with customers in developing and assuring that the design of the brackets will fit in your particular situation and can offer these as specials. Or we can even work with customers in providing outline drawings of the modules or even, for instance, the base unit, so that they can create their own customized installation. So the 110 gigahertz module in this case for this particular bracket will mount right on this bracket assembly. And now if we just take our 110 gigahertz probe and mount it to the module directly, we now have a very tightly integrated system where the source and the test and reference down converters are located very close to the test port. And that, of course, is going to give us best raw directivity performance, which means best calibration stability over time and over temperature. Now, notice the distance from the probe holder to the tip of the probe. So that's one aspect that you want to take into consideration when mounting and evaluating the mounting capabilities on this particular platen and probe station. So the distance from the probe holder to the probe tip is about 2.5 inches, and it's about 1 inch, a little bit less than 1 inch from the probe holder down to the tip. So those are the two things you want to take a look at when determining if your existing positioner will mount the module assembly in the proper location. So for example, here's a 145 gigahertz bracket and the 145 gigahertz module with a 0.8 millimeter test port connector can slide right on to this bracket assembly and mount on that same RF probe holder. So you see, this system, once it's set up properly, can be easily converted from a 110 system and upgraded to 145 or 220 because it uses the same concept of these brackets. So another aspect of the probe station and platen layout to consider is the opening. So here we have a little bit more than 12 inches of opening between the two platens. And so as long as your positioner can be mounted in the proper location on the platen in order to create the right amount of separation between ports 1 and port 2, then you have the capability of installing this concept on your probe station. So it's just a matter of what type of probe station you have, the type of platen, location of mounting holes for your positioners. You may already have positioners with probe holders like this, and just to verify, that you have enough space to mount these modules with this bracket assembly in a position that will reach to the center of your chuck. So here we have the 220 gigahertz module bracket assembly. And you can see it's very similar in concept to the 110 and the 145 gigahertz. And they're just small adaptations for each of the modules. And so with our 220 gigahertz module now, we can insert it in this assembly and mount it on our probe holder. And so here we have the 220 gigahertz module mounted on the bracket assembly, and I have a dummy 220 gigahertz probe so that we can see the idea about mounting this system on this probe station. And so again, the same concept of just mounting the assembly onto the RF probe holder will give you an idea of the space between the platens that's required and the distance to the chuck. And again, this positioner can be moved back or forward depending on the holes that are available. So that's the first thing you want to do, is check on the positioners that you have with the RF probe holder location over your chuck and the kinds of variations in distance between the two positioners that you can achieve. And that would be either by moving the positioner on the platen back and forth, as well as adjusting with your micro adjustments how much room you have between the two. So in this case, the positioner is from form factor. It's RPP 305 model. I don't know if they still have that model or something that's similar with a different model number, but the basic concept is always going to be the same. And so that's why you would want to look at the different options that are available, or the ones that you already have on hand. And so this platen is a basic platen that's also available from form factor, and it's installed on a number of different probe station models as well. And so this particular probe station is the PA200. It's an older series, but the concept is fairly similar between models. And so here we have a pair of 220 gigahertz modules mounted on the bracket assembly that we were showing earlier, and the assembly is now on the RF probe holder of the RPP 305 positioners, and that is mounted on the RF platen that's from form factor. And so in order to confirm that we have enough adjustment in our positioners in this position, we will bring the modules together until the probe tips are just about touching and at the center of the chuck. So that confirms that we will be able to reach all the dots on the wafer with this setup. Also notice that we have raised the chuck until the probe tips are just about touching as well, in order to confirm that we have enough height adjustment in the positioners. And note that we are using a isolator, and the isolator is used typically at millimeter wave frequencies in order to minimize potential parasitics as we get higher and higher in frequency. So that's becoming more of a common practice. And so it's also good practice to support your interface cables with a cable support mechanism. And that will help to reduce any kind of movement after calibration. So it's a good idea to have that in mind when you're doing your setup. And then finally, notice the height of the VNA. Getting the test set and test port of the VNA up to as high or a bit higher than the bridge that's on the back of your probe station is the best way to minimize the length of the cable going from the VNA to the module. And so our 1 meter length standard cables usually can accommodate most applications. So if you do not have the modules and the probes available, and what you're doing is trying to confirm if you can position your RF probe holders in the proper place in order to accept these systems, then what you would want to do is confirm the probe holder distance to be in the vicinity of where you need them for the modules. So for instance, in the 220 case, the center line from probe holder to probe holder is about 5.5 inches. And it's about the same for infinity probes at 110 and 145 gigahertz. So if you were evaluating your setup for the 110, 125 gigahertz VectorStar system or the 145 gigahertz VectorStar system, then you'd want the separation of the probe holders to be about 5 to 5.5 inches as well when using infinity probes. If you're using GGB probes, then it could be a bit shorter in the 4.5 to 5 inches range. So in fact, GGB offers different lengths of probes for the 145 system probes in order to accommodate for different installation setups. So again, you know, it's a matter of working with us, working with your probe manufacturer vendor to verify which versions you're going to be using. So that's the separation requirements. As far as the distance above the chuck, you want to be about 1 inch from the probe holder to the chuck. So with those two things confirmed, then you can be confident that the VectorStar Broadband system is going to install on your existing probe station. So another example of the versatility of the nonlinear transmission line modules is the ability to mount them in the north-south orientation. So if you have wafer where you have guts that need to be probed in the north-south orientation, you could still do that with these modules and include some extension arms on your positioners. So here we have some extension arms that are supplied by the positioner manufacturer, and using the same RF probe holder and the same brackets, we now are installed in the north-south position. Notice that we have the VNA now located to the side of the probe station instead of behind it. If it were still behind, we would need a longer interface cable to reach the south module. In this setup, we can use the same standard 36-inch interface cables and reach the modules with no strain on the cables. Now, if you have a 4-port DUT, you can install, of course, a 4-port VectorStar Broadband system and reach all the modules and all the ports as needed with extension interface cables. And if you have certain custom installations that you would need support on, we could work with you to provide the length of cables that you need in order to adapt to whatever condition you might have on your probe station. So here we have a close-up of the installation when mounting the modules in a north-south orientation. So because of the compactness of the nonlinear transmission line modules, we're able to take these adapters, which are available from the positioner manufacturer, and mount these modules and still clear the scope and the bridge of the probe station. And also notice, because of the smaller footprint of these positioners, there's still room enough to add an additional positioner in order to mount other things, such as, in this case, we have a GGB multi-pin bias probe connected. So we've been discussing how you can mount the Anritsu nonlinear transmission line millimeter wave modules using the bracket assembly directly on the form factor positioners. So the form factor positioners have a set of mounting hole patterns that are spaced in according with the platen. And so with this combination, we have a wide range of choices in terms of positioner positioning, so that we can optimize the placement of the module and probe relative to the chuck. But what if you have a positioner that does not mount exactly where you need to, or the platen does not have holes exactly where you need to? Well, there are options that you can use to adapt to that, and so we'll discuss that next. So if your platen does not have mounting holes in the location where you need to place the positioner, then one option is to make some type of adapter plate. So like, for instance, if you make a plate with the hole patterns that mount to the platen and align the positioner in the place that you need, well, then you'd be able to mount your module and probe exactly where you would like it to be. So this is often a way to resolve the issue, especially if you have multiple locations on your wafer and you're not able to quite get to the position you need to. So this concept would also work with even other types of positioners. So if you have a positioner from even a different manufacturer, you could do the same thing. So for example, let's say you have a MPI positioner with the 220 gigahertz bracket. You know, that would also allow you to mount on the platen at exactly the position that you need. So for this example, I've installed the adapter plates that we were demonstrating earlier onto the form factor RF platen, and these adapter plates have mounting holes that will mount the MP80 MPI positioners onto this platen. And so by mounting our 220 modules into this bracket, we now have the ability to use the 220 system on a form factor probe station using the MPI positioners and their 220 gigahertz brackets. The difference in the bracket and positioner mounting of this system is that it gives you a little bit more flexibility. So for instance, you have the ability to adjust the height of the module over a little bit wider range, and for things like when you want to pull back the modules safely, you can unlock the set screw and just slide it back. So there's again, a few differences between the different capabilities of different positioners and the way that they mount the modules. Now, another thing to notice is that when we push the modules forward, as we have here, it creates an opportunity to use less of an opening in the platen. So I was showing earlier the 12-inch gap. We weren't using up the entire 12 inches, but in this case we've actually reduced the gap required down to 8 inches. So if you have a probe station where the platen is similar to what we have here, some kind of a circular design where it's not quite as open as it is here, then you can use a different arrangement of the modules on the bracket holders to reduce that opening requirement. And we found that 8 inches is about what you can achieve with a minimal opening. In this video, we discussed the different installation options that might be available when installing the VectorStar Broadband system on probe stations. We focused a bit more on the 220 gigahertz installation, since installing the 220 gigahertz modules on an existing probe station has been a common interest. However, the technique that we described is useful for any of the VectorStar Broadband systems, including the 110, 125, 145, as well as the 220 gigahertz system. So if you have a probe station and are interested in knowing if the VectorStar Broadband system can be installed on your station, you might want to first contact your probe manufacturer to see if they might already have a solution available. If you have a more unique situation and would like to discuss with us further, please contact us and we'll be able to provide more information on the types of choices that might be available. Thank you for your attention.